Okay, so this is Will, and I want to show a little bit with the Factor I/O, which I think is the best tool for learning how to do PLCs. But I ran across something that I thought was pretty outrageous, and I don't know, probably everybody knows about this, except for me. But you can almost use the Control I/O, and here we're going to use the Control I/O, so you don't need a PLC. Normally, when you need a PLC, you need to download everything into the PLC to get Factor I/O to work. But when you're working with Control I/O, it's almost interactive because you don't have the PLC and you aren't doing any downloading. So we're going to take a look at the this assembler, which basically it'll just the emitter will just emit lids and bases. There's a pick and place machine that comes down, picks up the lid, moves over here, puts it on the base, and then after they're mated together, we lift up this bar and we send it on its way. There's also a little counter circuit here. Now, if we turn on lock all tags type of deal, well, let's just take a look at how it works, and then we can go through our normal setup for what we do, and we want to make a roadmap for what signals we need. So here we come down and let me reset it and go at half speed. It might be a little better to take a look. So comes down, we get these are the lids, these are the bases. So it comes down here, it'll clamp this, it'll come down, pick it up, move it over, put it down on the base. When it's mated down on the base, comes back up. When it's up, you lift up the bar and forward. Now the sensors that we need, when it's coming down and another one is coming in place, there's this lid at place, and you can see that it goes high and then it goes back low, and when it goes back low is kind of when we want to clamp it. So that's kind of what we want to do for our project. Counter when it's finished processing, so it won't be finished processing until it gets eliminated down here. So that'll continue. So let's take a look. Let's just pause it for a second and come back and start. So now when we want to take a look at this is the Factor I/O, and we go in our scenes, and it is called the assembler. There's two. One is an analog. We're just doing the assembler, and it's a 2-axis pick and place. So we pull that up, and here's what we have. This again shows all of our sensors that we have. And again, the first thing to do is just to take a look at what signals we're going to need and how we're going to do this. So again, I think the best thing to create your roadmap is to dock all the tags. When you do this the first time, let's dock all my tags. Most programs that we have, the emitters and the removers are already forced on. And you can see they're forced on. I guess this is a new version where it actually lights up. So if we take it off, we release the base, you can see that that one turns off. So we know that these are the bases, so these are the lids over here. So what we want to do when we start out is we want to turn it on. We're going to turn on the emitters only long enough to where it actually forms the actual unit. And then we're going to turn it back off. And what we're going to do is turn on the conveyors. So we want the base conveyor on. And we want the lid conveyor on. And now when it gets to this position, what we want to do is we want to take a look and we want to clamp this. So we want to clamp the base in place, and we want to clamp the lid in place. And you can see there's a signal that says base is clamped. So now we're going to clamp the lid. Okay, so now these are both clamped in place. We can turn off the conveyors. What we're going to do now is we're going to drop down our pick and place. Now we're going to drop it down. When it gets in range, we're going to grab it, and then we're going to let go of the clamp. We're going to lift it up, move it on over, and put it down on top of the base. And again, we're going to that wasn't what I wanted to do. latches to reset it. I want to turn down the speed of the clock. So let's release it, and I'm going to go back to normal speed. And what I want to do is I want to turn on the emitters really quick again. So emitter there is on, emitter here is on. I'm going to release them, and turn on the conveyor. Base conveyor, lid conveyor. And now we're going to clamp. So on base, turn on the conveyor. Let's clamp the lid. I want to clamp. Turn that one off and now release that conveyor. So now everything is in the position for clamping. So now is where I want to slow down the speed here. So I'm going to go down to a small speed, and what happens is to lower this pick in place, I just say I want to move in the Z direction. And as I'm moving in the Z direction, when it is actually moving, it'll say it's this bit moving will go from inactive to active. So I'm going to force the move Z on. And again, I'm going super slow, but what I want to do, and I'm going to hold it here, as it gets closer, it's going to say that I've detected an item. And as soon as I see that signal go high, I'm going to unpause it again. And it goes high. So now I want to grab this. But first I want to show you, so when that signal goes high that it detected it, it's not all the way down on the device, or the lid itself. So it is still moving in the Z direction. But what I want to do is I want to turn on my grab at this point. I'm going to force that suction on. And when I unpause it, it's going to go down and it's going to grab it. Now as soon as it finishes the movement in this moving Z, is I want to release the lid clamp. Okay, so as soon as I'm going to unpause it, as soon as I see the moving Z deactivate, I'm going to pause it again. So right there, it went to deactivated. Now I'm going to release my clamp of my lid. And now since the clamp lid is released, now when I'm also going to restart it, I'm also going to turn off the Z direction, and now it'll go up. So now when I release that, you can see that that clamp went up, that went. Now when this again stops, this moving Z, that means it's fully as high as it's going to get. Now I want to force it to go in the X direction. And again, the moving X bit goes over. And that bit goes off and deactivates. That'll mean it's... I'll stop it. And it stopped right there. That means it's directly on top of the base. Now, what I need to do is I need to go down again. When I go down, I need to release the grab, and then I need to go back up. And when I go back up, I'm going to lift this bar here. And when that bar is lifted up, then I'm going to turn on the conveyor again, and then send it on its way. So, those are all the tasks that we need to do. So I'm going to come back. I'm going to unforce, or release everything, and we're going to take a look at a clean slate for the control I/O. Okay, so now I've released all the ones that I had forced on. I've reset my system. What I've done is I've gone into my drivers, I put in the control I/O, and I've got a blank control I/O screen right now. So we can start making our program here. And the way I like setting it up is I want to see the sensors over here so I can see their names. I want to see the actuators over on this side, so I've got their names too. But the first thing I want to do is I want to go in and I want to take a look at we talked about making the roadmap. So how are we going to start writing the code? First, I'm going to have this start, I call it the start process, but it means after I push the start button, I want to latch a circuit that's going to be used to say, yeah, we're sort of turned on in the operational mode. And the first thing I need to do is I need to create that emitter signal. And we had the emitter signal there just for a short period of time, and then we turned it back off. And that's what we want to do here for this demonstration. So I'm going to, as soon as I hit that start, I'm going to turn on a timer. I'm going to have two timers, one for the lid and one for the base. And they'll be for 1 second, because if you have the emitter on for a very short period of time, it's not going to be long enough for the emitter to actually form for the I/O. So you can't use a pulse. You have to put a timer with a good bit of time. So what I'm going to have is the timer, and it's going to be 1 second. So that emitter is going to be on for 1 second. As soon as that timer times out, I'm going to turn off the emitter signal, but then I'm also going to come down here and turn on the conveyor. And it's going to be that way for the lids as well as the base. So you can see I have these little arrows that I kind of draw that says on that falling edge, or when the timer times out, it's going to turn off the emitter. It's also going to turn on the conveyor. And the conveyor is going to go down. And then we saw that there is that signal that said that when either the base or the lid is approaching, and the signal is called at place. I'm not quite sure what that means, but we don't really care about that front edge. We want to know when that back edge is approaching that. And when the back edge has passed that sensor, that's when we're going to clamp either the base or the lid. And then when it's actually in the clamp position, we get that feedback that says it is actually clamped. Then we're going to turn off these conveyor, either one of them. Now, when the base is clamped, well, actually, when the lid is clamped, the first thing we need to do is we need to move that z-axis in the down direction. So we need to move it in the down direction. And then we saw that we have that idler detector signal that went active. As soon as that signal goes active, we're going to turn on that grab signal. And once we have that grab signal that says, yeah, I've grabbed it, now we're going to turn off lid clamped signal, and then we are going to start to go up. And we can latch and set and reset a lot of these logics to say, because we have to go up and down a couple times. One of the questions is, we say the first time we go down, do we have a lid attached, or have we grabbed it yet? And the answer is no. The second time we go down, we will have grabbed it. Now, you can either use the fact of whether you've grabbed it or not to know what step you're on. Another thing you can do, and if you have a number of steps, is you can actually count steps. And that's what we're going to do here. So every time we get these moving signals, and they go from high, which is I'm moving, to low that says I'm finished moving, we're going to count every time we've finished it. So the first time we go down to pick it up, we're going to count from 0 to 1. And so if the count is 1, we know to pick up the item. We go back up, and then the count is 2. Then we know to move over in the x-axis. And if we take a look at that over here, basically what we have is, we move in this z direction, we move down. When we move down, and we want to make sure we move down when the count is 0 and that lid is clamped. Because if the lid isn't clamped, there's not much good we're going to do by moving down. But then when the count is 1, we're moving up. And the count is 2, we're moving right with the lid. And then, again, when the count is 3 and the base is clamped, we have to have both of these conditions. We're going to move down again. When we get down, we're going to release the lid onto the base. And then when the count is 5, which means we've moved up again, we're going to finally move left. And we'll also have cleared, the position where the lid and the base come together, so then we can raise the bar and we can send it on its way. So we're going to move left, we're going to raise bar, and then we're going to turn the conveyor on to again go back to the remover circuit, and we're going to send it on its way. So let's take a look at how we're going to do that on our control I/O logic. And the first thing we want to do, and I guess we're going to have to pull up our tags here, is we're going to take a look at our start-stop, and I'm going to put in the stop signal. I'm also going to grab my start signal. Now, because the stop is normally closed anyway, what we're going to have to do is we're going to have to throw it through a NOT circuit. And let's see, we'll go into here, straighten it up as much as we can, and we're going to go through the set reset. Now they have two that are set reset and reset set, and you can tell the one that is the dominant one, so if these are both 1, it's going to be in the reset, or the output is going to be 0, and that's in general what we want. So this one, when the stop goes active, we reset. When the start goes active, we're actually going to set it. And what I'm going to do for my memories, and because I'm going to use it in a couple places, I'm just going to put this to a Boolean. And the way these Booleans work is, when I pull one into the screen, it's going to come up here. And I'm just going to give this a name that says this is going to be my start process. And that shows up there, and that's kind of nice. So now, what I'm going to do is, when I have my start signal, when I first hit that start signal, I'm going to start that counter that starts for 1 second. So what I'm going to do is I'm going to actually run this through a rising edge trigger. And, I can probably position it about there. So it's going to go into start, and now that is going, and what I'm going to do is I'm going to put that through an OR gate, and for the time being, I am just going to tie both of these inputs for the OR gate to that signal. Now, the reason I'm doing that is this signal is going to send out the first emitter pulse. But after I finish with the circuit, I want it to keep going. So at some point, I'm going to disconnect the second input, and I'm going to put it into another circuit. But we're not quite at that point yet. So what I'm going to do is I'm going to take that output, and I'm going to, again, put it into a reset signal. And so when I get that pulse, I want to set it, right? And I want that to set, and that output I'm going to put into a timer. And so I'm going to pick a timer, I'm going to take a T-on timer. Now here, for the T-on timers, that signal is just going to make it active. So when that signal is active, it's going to be high. Now, how long is it going to be high? Now, for this, it's going to be fixed time. So if we go to the top of where all of our tags are, there's also something called sources. And sources, I just want to pick a numerical thing. And these are in milliseconds. So I said 1 second is going to be 1,000 milliseconds. And that's going to be my preset timer for that. And all I'm going to do for this, again on the output, is I am going to go back into my memory, and I'm going to say that's a Boolean. And now this is going to tie into there. So when I finish timing out, I want to know that. And when I finish timing out, that is actually going to reset this. So actually this Boolean 1, when I highlight it, I'm going to call this T1, and I'll just put underscore done. And now what I can also do is I can take that one, I can copy it, and I'll just paste it and move it back over here. And now that is going to be my signal that is going to reset this signal here. But now, what I want to do for my actual signal that's going to control my emitter, so this is going to be high for 1 second, and as soon as this goes high, this is going to reset this. So I'm going to take this signal along with my start process. I'm going to throw them through an AND gate. So AND 2, and this will be one of them. This will be the other one, and I'm going to say that is going to be my basis emitter. And now because this is an output, it's going to show in red. And at this point I'm going to lighten it up. So your inputs are green, your outputs are red. So that is going to get me my emitter signal from my basis. Now, so what am I going to do? I want the exact same setup for my lids. So I'm going to copy all these guys. So I'm going to do Control C, Control V, and then I got to move them all down. And I'll try to get them down underneath this. And so here I've got the start, and this part of it, I don't really need this part of it. I need the retrigger, that, I need this thing, that, let's see, that I do not need, so let's delete that. And, but what I do want is I want something that I want to capture these three guys also. So I'm going to copy these and paste these back down here. Actually, I kind of want to move these guys one over this direction. So, what do I have for this? So, I want the same thing, except for this one, I'm going to have to change this to, I'm going to call that T2, and I'm going to, so I changed it to address 2, but I'm also going to call it T2 done. I'm going to go to this guy, and I'm going to change him to 2, and then what I'm going to have is I'm going to have the output here. So that should give me, and I don't want this guy to be my basis emitter, I'm going to change that one to be my lids emitter. So there's my lids emitter. That's what I've got there. So hopefully, you know, that's all it's going to take, and that's what will get us to our lids emitter. Now, the next thing I want to do is I want my conveyors. So what we're going to do is kind of a similar type of thing, but when we have the T1 turn on, so what we're going to do is we're going to take this guy, copy and paste him, and we'll move this guy down here. And now this is going to turn on the conveyor, but I know I want to turn my conveyor on several times, so I'm going to do the same type of thing temporarily. Is I'm going to put an OR here, and I know the first time I'm going to turn it on is going to be with this, but then I'm going to need to turn that on a second time, because I'm going to turn it on until it gets to the clamp of the base, but then at some point I'm actually going to turn it on a second time. And that'll be true for the base, but it's not going to be true for the emitter, because the base, I have to send it on its way a second time. So what we need to do here is we're going to tie these together for the time being, and we're going to run that into a reset set register again. And when we see that go high, we're going to turn it on. And we're going to say that that's going to be our basis conveyor. So we'll try to put the outputs kind of all in the same area. Try to line him up. And likewise, for what we did before, is I'm going to copy that guy. Well, and for right now, what I need for the reset, we said, again, the input that we get is, we get the base is clamped. That's an input. So when I get the base is clamped, is when I'm going to reset that conveyor. And let me try to move down a little bit. So I want to turn off that conveyor when my base is clamped. And I'm going to want to do the same type of deal for my lids. So I'm just going to copy them, paste them, and then for this one, now this one we're only going to run it one time, so I don't really need this OR gate here. So I can delete him, and I want to also change this one to T2. So I'm going to change that into T2. I'll run him right into there, and instead of this being the bases clamped, I want this one to be the lids clamped. And again, be careful because there's clamp lids and lids clamp, but we want to make sure it's the input sensor that says the lids is clamped. So I'm going to just delete that guy, and I want lids clamped down here for the one that's going to reset this guy. So let's bring him down there, and then this one is not going to be bases conveyor, it's going to be lids conveyor. So delete him, put the lids conveyor out here. If we connect him, that'll be right there. So hopefully, and if we can go into driver's circuit here, we'll take it off pause, and let's see how far we get. So go in here, do this, comes down here, and okay, now it's clamp, and our conveyor is still turned on. So let's take a look at this. Oh, we didn't put it in the circuit, actually clamp out. So we have that circuit, and here's the one thing I think is really cool. Now to talk about the interaction, maybe show it a little bit. So what I have to do here is I have to go and I have to put in the circuit that tells me when to clamp my base, clamp my lid. So I have that signal that says base and plate, place. And we said for that one, we're going to look at the trailing edge. So we want the falling trigger. So we're going to put a falling trigger in there. And we're going to put that in with the SR signal. And I think this is going to be a really cool part. So, and this is the interactive part I was talking about. So right now, we aren't clamping anything. There's a work. So it's well, I can tell that there's still running. Here a little bit, you can see that they're actually running. But what I wanted to do is, so at this point, we're going to the output that says we're going to clamp our base. it already went past the time to work, but if I reset this, let's go back here, reset it, and let's turn it on again, and we'll see if the base does actually clamp this time. So you can see the base clamp and then cut off. Now, we couldn't see that in real time because what happens is the signal goes high and then goes back low. And that's how it's set. But what we want to do is we want to take this center and we're going to copy it and paste it. And we're going to do the same setup for the lid. So this one's the base at lid, or lid at place. Delete that, this will be the clamp lid. So now it's going to reset each point. Well, first, let's see if this is not quite broken. So I'm going to go back here and set these. And now let's run it once again. Now this should take us all the way and notice where everything is clamped. So now everything is clamped. And now we're at the point of where we want to start moving these down. So when we move it down, and again, if we go back to the point here, when the count is 0 and the lid is clamped, we're going to move down Z. Okay? And that, when we go all the way down and we see that the item is detected, we're going to turn on the grab circuit, and then we're going to lift it up. So for that one, and the first thing we're going to do is we're going to have our initial thing for the move Z. And for somewhere down here, well, we're going to have a reset in for both these circuits. So we need something that's going to be further below. And for down here, we're going to have, the first one is going to be a move Z circuit. And this one is going to be down here. Let me move it down a little bit. Now the first thing we know is that we say that we're going to have a count, and we're going to have to set up the counter too. But we're going to have some, well, I can put in a counter. I'll do my counter up circuit. And move that. And I can move that down here, I guess. But the first thing we're going to have is that. Down here, and the relational equality, and I want it equals. So there's two conditions when I'm going to move my Z, and it's going to be, and what I need from my counter is the actual count value out here is I'm going to have to put in one of my memories. And from my memories, this is going to be an integer. And that'll be the actual count value that I want in here. And so what I want to name that is this first one, I don't know, I'll just name it my move counter. And that's going to keep track of all our counter moves. And so with my move counter, I'm going to copy him over here. So when my move counter equals, and again for this other one, what I'm going to have to do is put in a numerical thing. And remember, these are in milliseconds. So when you're doing this, the numbers want to be just 0, 1, 2, or 3. They don't want to be in the thousands. So when the move counter is equal to 0, okay, and, so I need an and in here, and my lid is clamped. So lid clamped. So when that is there and it's clamped, then I'm going to want to set this to run. So what does that look like? I want to reset set again. And there you can actually see when I finished that circuit, it did go down. So that tells us it's correct. Now, so what do I want to do? Well, let's just show it going up for a second. So what do I want to do to reset that thing? So now, you can also see, well, I've got to put in my counter. So what's going to do my count? Because what we said is when the count equals 1 is when I want to go up. So how do I actually have my counter count? So I'm going to have the counter count when either my move x, or not my move x, my moving x or my moving z, actually I see a falling edge. So my moving x or my moving z, and for both of these, I want to see not when it initially starts moving, but when it stops moving. So that's going to be a falling edge again. So you want to use these falling edge signals. And then it's going to go through an OR circuit because I want either one of them to cause that. So I put this in here, put this in here, and put that into there, that into there. And now, as soon as I connect this, well, it's not going to count right now because it won't see that rising edge. It won't see that falling F trigger. So if I can reset it again, it will see the count. But what we want to do is, for the reset, we want it to be, when the count is 1, we want it to reset. So really, I kind of want to move all this stuff down a bit. And what I want to do is I want to put this circuit in. I want to copy this. Now what I want to say is, when the count is 1, I'm going to copy that. I'm going to reset. So when the count is 0 and I have my lid clamped, I'm going to move it up. Or I'm going to move it down. I'm going to activate it, which moves it down. And then when my count goes to 1, I am going to reset that, which deactivates it, and it's going to go up. Now at this point, it's not going to have it clamped. I'm going to have to put those circuits in. But we're going to have to put in these comparators for every time. So it's going to be at 0, it's going to be at 1. For right now, what I want to do is I'm going to take this, and you can see when you do that, it kind of changes the value. What I want to do is I want to copy it, I want to paste it, and I'm going to make my preset value over here because we know we have 6 steps. So I'm going to make that my preset value. We'll deal with the reset later. But let's take a look at this. And so if I reset it, and go through, now what should happen, reset, and start it again, it should go down and lift back up, and then it should stop. It's not going to grab it at this point because I haven't activated it. So now it goes down, and goes back up, and it stops. So what happened was, we had the count 0, it activated that, and then when the count went to 1, it deactivated it and went back up. So I'm going to take a break here because this is running quite long, and I'm going to put in a bunch more of these to match exactly what we said we were going to do in this circuit, as far as when the count is 2, 3, 4, and 5. And we'll come back and take a look at that. And that should get fairly out along the way. Alright, this turned out to be a lot of work here, but let's take a look at what we have again. So on here we're saying we're moving down, so we're activating Z when count equals 0 and count equals 3. We're moving up when count equals 1 and count equals 4. So what we have to do in this logic is when count equals 0 and count equals 3, we are setting it, which means we're moving up. And then when count equals 1 and count equals 4, and either one of those are an OR condition, we're resetting it, which makes it go down. So we've got, or makes it actually go up. I can get my ups and downs mixed. So when it's 0 and 3, it's going down when it's active. When it's 1 or it's 4, it's going up or inactive. Now, another thing that we have in here is, if we look at this, so when count is 4, it's also, well, when the count is 4, so what we're doing is, we're also saying that's, well, when the item is detected, we're grabbing the lid, but when the count is 4, that's when we're going back up. That is also when we're letting go of the lid. So we're saying that lid, when we're grabbing it, is when the item is detected, and then when we have the lid grabbed, that's on that count of 4. Now that count of 4 is what we're resetting the lid clamp. And likewise, down here, when we're moving X, we say that we're moving X when the count is 2, and then we're resetting it when the count is 5. So it's not X here. Now at the same time, I'm going to raise that bar, and this also we say is when we're releasing the part. And we need to release the part to release the latch on our clamp for the base. So when we release the part is when we release that base clamp. When we say that we're no longer, grabbing the lid is when we, when we grab that lid is when we're releasing the clamp on the lid. So let's just take a look at this table, and that's what our count is. So now, if we look at this in our factory I/O, and we'll reset it, what the logic is right now is when we turn it on, they go down, just so here when they clamp the conveyor, stop it, comes back down, drops it. And at this point, this base goes up. We have some work to do. So when that base is up, right now what we need to do is we need to turn that conveyor back on. And we need to turn that conveyor on when this part, again, this is the leading edge, this is the trailing edge. When that trailing edge passes this sensor, we need to make that bar go down. And then what we're going to do, and I can probably do it right now, is we need to get away from the run mode and put in exit mode. And I don't need that, but what I want to do is I want to take this sensor here and I want to make a duplicate here. So I'm going to take that sensor and I'm going to move it right to the end here. And I wish I could get this right. Let me try to move it a little better this direction. So it should go right about there. So now what we're going to do, and now it's called diffuse sensor 4, but what I'm going to do, if I can find it in here, Okay, diffuse sensor 4. I'm going to change that to conveyor exit. That wasn't what I wanted. Well, let me delete that. And let's go back in here. I want to duplicate that. I want to move it to right there. If I find it again here, I'm going to click on that. And let me go back into here. Make sure I don't do that. Now if I change this name. Okay, so I'm going to call it conveyor exit. So right here, when it goes past this sensor, I'm going to drop that clamp bar. When it, again, the trailing edge goes back there, and you know, as soon as I raise this, I got to turn this conveyor on, but I want to turn it back off when it passes this sensor. So what I'm going to do is I'm going to put in the final touches for getting that done. I'm also going to take a look right now, and you know, I have this remover 1 and remover 2. This one is forced on. I want to also turn this one on. So let's see which one this is. If I release this one, so remover 1 is the one I want to activate. So I want it to automatically make this disappear when this comes down. So what I'm going to do is I'm going to activate that when this conveyor exit is strobed, and I'm going to turn that on probably with the clock for a certain amount of time. So let me just go back, make the final touches, and then we'll run through the whole finished project. Okay, so if we take a look at the very final things that we did, you know, we had it so the bar would be raised, but we needed to turn the conveyor back on, and we needed to send it on its way. So we put this conveyor exit in there. The first thing we did is, as we turned it on, so we had this bar go up, and we're going to bring it down when this part leaving signal goes active. Well, actually, when we see the falling edge of it. So, if I can widen this guy back out. There we go. So, when the part leaving on its falling edge, it's going to reset that and make it go down. Then we have this conveyor exit, which our new signal. So first, we also have this release part, and this release part is going to turn on a conveyor. Then we have the conveyor exit. When it gets the falling edge, it's going to turn on the remover signal, and it's also going to have an at exit, which is going to turn off our conveyor. And then we have this also, so we have a remover and at exit, and then we're going to have a signal that'll keep our remover on. Like right now, we don't know exactly how long it's going to take for that box to go sliding down and to get removed, but we're going to put it at 4 seconds. And then that final, when it goes high, we'll say that's the end of our cycle. And what are we going to do at the end of the cycle? We're going to reset the remover and the add exit signals. We're going to count our box as processed and finished. So if we go up to the very beginning, you know, we said that we put those OR gates in, and we weren't quite sure what we were going to do to send out the second box. We're going to use the end of cycle there. I'm not quite sure why I got 2 of those there. So the end of cycle, so we're going to use the start button to send the first box, and then the end of cycle is going to send the second one. And we do that for both the lids and the emitters. And let's see, so that's what we use for the end of cycle for the second time around boxes. And then if we move further down, we use the release part to turn our conveyor on, and then when it gets at the at exit, so it gets past this sensor, that's when we use to turn the conveyor off. So, you know, last time the base, this rod went up, but the conveyor didn't start. The conveyor will start when that happens, when we release the part. So the conveyor starts going. When the back end of the part passes this, it'll drop the bar. The conveyor is still running, and then when the back end of the part goes past that sensor, it'll turn this conveyor back off. So that's what we should have, and then we should make the count, the official count at the end. So that hopefully is the way our program is going to work. And let's take a final look at it. So break it down. Clank, brings it up, things down, goes up. So that something is wrong. Yeah, it didn't go down. Actually goes down. So let's just stop it there for a second and take a look at this. Where is our bar? Okay, so this is raise the bar. Let's take a look at this. Now let's reset this. Start it. Okay, so our signal, you can see that it started to turn off, then it turned back on. So what we really have as a problem here is, what we really need to do is want to, instead of, this is just the equate signal, but what we really need, because this is actually at that count for after this trigger signal is there. So what we really need to do is delete that and put this as a rising edge. And actually, for all these set reset things, it's a good thing to put triggers in there, so that in case that this signal is, the counter is at that condition where it's equal for longer, then that escapes it. These rising edge and falling edge, they're only true for one scan. So that should take care of our problems, I think. So let's reset. Let's go. Let's see if that gets going. And I guess I really didn't see how you could do that. But one of the things that we can show, let's see. Oh, that one didn't go quite right. Let's see what happens. And also, that counter is probably, we have it set up for like 4 seconds, I guess, for the counter circuit. But that can probably be a lot less. So, let's see. That's on for at least a good second, 2.5 seconds too long. Let's take a look at that very end function. Let's change that 4,000 to say 1.5 seconds. See if that works a little bit better. And you can see it in the background here, what's going on there, and you can kind of put whatever kind of logic you want to look at. So we're taking a look at the 2.5 looks better. And that makes it run a little faster. Now, part of the thing that we were saying that you can see interactively, try to zoom this a bit first. And you can see our counter is counting now. But if we go in here, we said we had that one, and let me just the function. And our very first one was, click on that. Our very first one was the start process. So if our start process, when we hit the start button, is also, and I never put them on there, but we start light and stop light. So let me put the stop light and I'll also see if I can find my start. So now, if I just make this connection here, as soon as I connect, I really want to put a notch in here too. Well, actually, I can hook them up both the same way. So as soon as I connect this start light to here, you can see that that light turns on. And that does it interactively. If you had a PLC, you can download into the PLC. Now, if you do it wrong, and I'm doing it intentionally, I put the stoplight in. The stoplight will light up as soon as I make this connection. Let it go. And now I know that's wrong. It shouldn't be both sides. Oh, what I really need there is I need a not circuit. So now I can go in and I can fix my logic, you know, sort of on the fly. And I'm not sure if I can do it for everything, you know, and especially the way that the edge triggers, sometimes you don't have to recycle the power. But I think that's pretty cool that you can, you know, take care of some of the problems as they're actually happening. So you can see what's happening with the line. One thing I didn't even realize that you could do that. I mean, obviously, with the control I/O, you don't load anything into your PLC, but I think that's a pretty neat feature. If I were factory I/O, I'd certainly be touting that feature. Anyway, that's what we have for the assembly. You can see what you can do with it. You know, it's, again, good thing with all your inputs, you might want to use these rising edge falling edges so you don't get into the type of problem that we had right at the not working. But, you know, if you can also use count steps and then just do comparators, you know, it works out pretty well. So that's it for somebody. Take care.